Today we are going to talk about color sensor and how it works. But first, let's talk about a simpler version of that sensor. It's the light and dark one. This sensor, I am sure most of us are familiar with it, and most of us has worked with it before. This sensor consists of two parts: the light emitting source and the light sensing part. It can identify nearby objects, and we can identify colors with it, but in a vague way. We can identify light colors and darker ones. We cannot get to identify like red and yellow and orange sort of identification between colors with such a sensor. It can only tell us that there is a color that's light or another one that's dark. That's it. So how to get past this and get a more complicated version to identify all of the colors that we see around us? So what are basically colors and how do we see them? Fortunately, and lucky us, we have a solid understanding of how the human eye works. And for our surprise, it only senses three colors, three fundamental colors: red, blue, and green. Here we have our simple color wheel. We have the three basic colors: red, green, and blue, and mixing them give us the rest of colors, and we can see here that we can get the full range of colors by only the three basic colors. What we need now are filters. Filters is a transparent material that is colored with any color we can choose. But of course we would choose to color it with the basic colors, the red, green, and the blue. This transparent material would only allow the color that it's colored with to pass through. And the only remaining thing is to place the photodiode behind those filters. And now we know that the reading of those photodiode would represent its color only, and that's how our sensor works. This is our sensor. As we can see here in this close-up photo, that it has an array 8 by 8 array of photodiodes, and these dots right here are the colors of the filter above this diode. So it works the same as we explained before. Here we have the datasheet of the sensor. We can have a look on it and its pins. It has 4 select pins. 2 of them select the frequency of the output, and we will discuss that now, and 2 of them to select which colors we are reading right now. This sensor is basically a current to frequency converter. Here we have our photodiode array. The more light there is, the more current it produces, as any photodiode would. And then this block of current to frequency converter converts this current to an output frequency. And we select 0 and 1, we can select the range of this frequency, and we select 2 and 3, we can select which diodes are we reading right now. Here we have the values for all of select 0 and 1, select 2 and 3. Here we have low and low red, low and high blue. High and low give us clear with no filter. That's like a normal photodiode sensor would do. And high is the green ones. And here we can scale down the frequency we are reading, and we have here the exact frequencies. So Let's wrap it up and see how to use this sensor properly. First, we need to select the filter we need to read now by S2 and S3, and then measure the output frequency to know how intense this color is, and then change the color filter to, and then we change the photodiode array to another filter and read again and again and so on. So to be able to measure this frequency accurately with our microcontroller, we could use external interrupt and timer, or we could use input capture unit. With the interrupt and timer, we could set the external interrupt to rising edge and then start the timer here and wait to the other interrupt happen again at the rising edge and then stop the timer and calculate it between the two, or we could use simply input capture unit which will do this for us. And thank you.